Hello everyone, and welcome to the first of hopefully many videos where we're going to build, or I'm going to build, a operating system that can be booted from a USB drive and launch a game. All the software involved will be written by hand, and you might be asking yourself, why would I do this? And it's partly to uh, learn more about low-level programming, but it's mostly because it's interesting and it's fun. So, excuse me. I've decided to also build all the tooling involved. So that's going to include things like an assembler, a compiler, and some other things that we'll need to help validate stuff as we go along. I will use a couple tools and open source stuff along the way to help build things, but in general, the goal is that any software that we run as much as possible will be, written by hand. Before we do that, we need to set up our repository a little bit. So I have a bare repository here, and GitHub has been generous enough to provide us a MIT license. So I'll go ahead and add the license file, make a commit for it. And I've also prepared a README file I guess we can do this. Basically just explains what we're doing and also gives some acknowledgments to some people that have kind of inspired me to do this. So Nick Blundell has a set of 9 videos up on YouTube where he builds an OS from scratch, kind of like what we're doing. He only takes it to where he's able to launch and run some C code. So that's giving us a great starting point. We're going to take it a little bit further, and we're going to get into being able to run a full-fledged game running on all of our software. A personal friend of mine, Kelly Leahy, was the one that introduced me to Nick's videos, so I want to thank him for that. And then I mostly deal in higher level languages, and I never had the opportunity to get into any low level languages in any depth. So I'd like to thank Casey Muratori, sorry for that, for doing the Handmade Hero series, which if you haven't heard about it, you would most likely be interested in it, where he's building a professional level game by hand from scratch, kind of the same thing that we're doing here. I found out about Handmade Hero from Jonathan Blow, who's another excellent programmer. Currently, he's working on building a new programming language specifically designed for games, so you should check that out. The other thing that I like about Jonathan is that he doesn't tend to put up with the state of things as they are, so he kind of sees problems and is not happy with them and wants to make things better, and that's kind of something that I try and do. I'm inspired by it, and I want to try and do some things like that too. So anyway, that's the README file, so let's go ahead and add that up. And then the last thing that I want to do is just start off with an empty get ignore file. If I could spell ignore right, that would be excellent. Yeah. Okay, so we have those things up, and so what I want to do is the first thing that we're going to need to do is start to write some of the boot code that we need. Before I do that, let's show what the bare minimum. I mean, we're writing an operating system. Let's see what it would take to just write what could be considered perhaps the bare minimum operating system. So I'm going to not do that. I guess I will. I thought there was a way. Here we go. Sorry. All right, so when you boot up a computer, the BIOS loads, and it reads in sectors that are 512 bytes long. So at the very end of that first sector, you need to have a boot sector signature, and that signature is 55AA. And what that's going to do is it's going to tell the computer, hey, this drive that you're looking at is the drive that you should boot from, and then it's going to look at the first byte in that sector and then start executing code, or executing the instructions on the CPU. So I'm going to, so right now we're just by hand, we're going to write we're going to write the bare minimum here, and that should be, okay. So I'm going to save this off to let's do this. What do I want to call this? This is going to be, I don't know, by hand bin. So this is a binary file, right? We're writing bytes to it. So what we need to do is we're going to use another tool or another open source project called QEMU, I believe is how you say it. And we're looking for, okay. So we're going to run the program, and we're going to run so we're going to launch, I'm going to go ahead and launch this right now, and what it's doing is it's saying, hey, I can't find anything to boot. It's going to go through its, simulated disks, and there's a network call in there to try and find it there. But what we're going to do is we're going to say, hey, use whatever we call this. So you notice now it looks a little different. It doesn't have that extra stuff, and it's just sitting there flashing. The reason for that is because, again, it found the boot sector signature, and then it started to execute the code up here. And these 3 bytes are the CPU instruction to effectively jump back to the beginning of, back to the 00 byte. So effectively, it's just an infinite loop. It's going to sit there and cycle. So in a way, this is perhaps the simplest operating system that you could write. It's also, in theory, the fastest. The CPU is going to sit there and spin as fast as it possibly can. How much harder could it be to write an operating system that can run a game? Shouldn't be much, right? Well, that's what we're going to be doing. So I'm going to shut that down, and we're going to use HXD here, but we're going to start writing some code now instead. So The first thing that we need to do is, obviously this is a Windows machine that I'm using to do development on. So there is a main, I think would work. So in Windows, there's a couple different signatures that you need to use to be able to start a program, depending on if it's a console program or a windowed program, when a program that has a window or a program that runs on the command line. We're going to start to write an assembler so that we can write assembly code and have that generate the binary needed to run on the CPU. So it's going to be a console program that we want to write at first. So the simplest, this is going to be the simplest console program just to get us going and start to build out some of the things that we need. So these arguments are going to be the command line input, and then this last one I believe is has something to do with the environment variables. If I could type the right key, helps. So here you go. This is going to be the simplest command line program in Windows. I'm going to go ahead and write it out, and I forgot to load it up in the directory that I needed. So I think I'm going to organize things a little bit different than what I maybe normally would do. So normally I would have a source folder here at the root. I'm going to go ahead and I'm going to separate out the assembler into a folder called toolchain and keep that separate from the actual source code of the operating system. The toolchain stuff are going to be the things that need to run on some other machine, like a Windows machine, that will help us to produce the operating system. We have to do this until the operating system becomes self-hosted, and that's where we can run our tools on the operating unit itself, building the operating system within itself, which, you know, it's kind of weird to think about at times. I don't know if we're going to get there. That's not necessarily a primary goal right now, but it could be. You know, we could see where we go. So I'm going to hopefully that makes all of it. Looks like it does. Cool. So then I want to dump this file into here, and I'm going to just call it main.c. There we go. Okay, so the next thing that we should probably do is try to compile this thing. Well, in order to compile a C program on Windows, we need to use the compiler that comes with Visual Studio. So that's usually in a folder within the program files. I happen to have, I guess I didn't need to close them, but here we go. I happen to I have some notes off here on the side that I keep referencing just so that I don't have to waste a whole bunch of time finding stuff. But if we do this, so this is just an environment variable. Oops. Bars, all that, AMD 64. I'm going to write that out to another folder I forgot to create ahead of time, which is going to be called I happen to have Visual Studio 2015 installed, so I'm going to leverage the C compiler from that version. And so basically what this is doing is it's setting up some variables and environment variables, sorry, that allows me to basically be able to call the compiler from the command line. So for example, if I type CL right now, it's like, oh, I don't know what that is. But if I were to call that bat file, then I can type CL, and ooh, there it is. It's the C compiler for Microsoft. So that's all that I did. That's all that does. So now we have that available to us, and so if the next thing that we would need to do is compile our main file, which, if you remember, had our has our simplest stub of command line program. Now we can write it all out by hand and run it from the command line every time, but of course that's not really what we want to do. So we're going to write a build file. I'm using set local and end local so that I can have variables within this build script that don't then pollute the environment in other ways. We're gonna take some time and do a little bit of overkill on the build script for right now. That's just because these are things that I know I'm going to want to have set up, and I'd rather just have it all done and not have to worry about it, and I have to remember, oh yeah, that's right, I didn't set the build up this way. Like I said at the beginning, I've learned a lot from Casey in the way that he's done Handmade Hero, so a lot of this is going to be there's going to be a lot that I effectively steal from him. So we're going to just set up a couple of things. So we're going to, by default, define the Windows API. I've chosen to use Windows API rather than Windows 32 just because I believe that Windows API is the preferred lingo nowadays than Win32, and I hate the whole 32-bit, 64-bit stuff and having to keep things straight, so I'd rather just say, hey, it's obvious we're running on Windows. Okay, right here what I'm going to do is I'm going to say, I'm going to allow for a argument to be passed to our build script. And if that argument happens to be the word release, we're going to go to the release. Otherwise, we're going to fall into the debug. And nothing's calling the debug, but I just prefer to do it so that it's more straightforward and you kind of know what that is, especially because we have that call to release. So we're going to set up that, and we're going to define a couple directives that we can use within our code. One's going to be obviously to let us know that, hey, we're in debug. So whatever code's flagged as debug, we want that. And then we're also going to have one around slow. So there's going to be a couple of things that we do where if we have something where we want to, while the operating system is running, we want, or what, you know, our tools are running, we want to do a little bit of validation or some other kind of extra checks, but we don't necessarily want to do that in the actual version. We can just put this slow around it and says, hey, it's okay to take a little bit of time here and double check things. This last one, I don't know if it's needed. The oops. Wow. The I gotta be honest, sorry. The help for the compiler and the linker are a little confusing. They're not very clear in terms of like when you need things and when you don't. And there's a couple things that are, hey, if you set this flag, then it changes this default flag's value, but then that one affects this third one. And it was just like, I have no clue. I give up. I no longer care. I'm going to do what I think I should do, and I'm going to move on until I find out that that's a problem and I should do something else. So here we're going to set our release settings, and that's basically just going to tell it to run in the optimized mode. All right. I'm going to set up some folders, not note. There's a data folder. Again, I got this from Casey. I kind of like it. It allows you to have a local folder, local to the repository, but not part. We're gonna add that to the git ignore so that, you know, we can put stuff in there, or I can put stuff in there, and no, I don't have to ignore it out or anything like that. It can just have stuff that we want to be able to use but don't necessarily want it to be part of the actual source code. And you'll see the kind of things that we put in here, and here's one of them actually. So I'm going to use Casey's timing executable. I hope that's okay. If not, we can write our own if that becomes a problem. What this is going to do is it takes snapshots of how long your compile times work. So I'm a big fan of fast compile times, and it's real frustrating when they're not. So we're going to do this, and it gives us, we can pull out some statistics on how long compiles have been taking, how often we're doing it, things like that. I kind of like it. So this is the actual line that's going to do the compile. We're just setting some flags. Something I haven't been able to figure out, and again, I'm not very familiar with the C, Microsoft's C tooling pipeline, or really any C tooling pipeline. I have my main file. I want to call it main. But if I do that, by default, all the output then is going to be called main. So our exe is going to be called main. Well, I don't want it to be called main.exe. I want it to be called assembler.exe. But if I say the output should be assembler.exe, none of the other, there's a couple other things. There's a map file, there's a debug file. I think that's in here. There, you know, it's like they're not connected like you would think. You know, I would think if I said my output is assembler.exe, all the other things then should probably be assembler dot, you know, whatever. It's not the way it works. It's a little weird to me, but you know, it is what it is. So we have to be overly specify and say all the name for all the things here. The weird thing is you don't have to give it the extension. If you just tell it the name, it automatically adds the extension. So that's where it's just like, how come I can't just say, hey, please name all the output this? Oops, there's our main.c file. And then we're going to pass our link, our linkers, link flags, excuse me. Like I said, I had this all worked out before so that we didn't have to A, sit through the drudgery of figuring it all out, and then B, waiting until we ran into it. This is a little backwards from what we should be doing. We should probably just add things as we need them. But, you know, it's kind of nice having a little bit of things here ready at the startup. So anyway, that's our build file for right now. So if I were to then run build, it says we can find the batch label specified compiler. Well, that doesn't. That's on. The thing I forgot to do. Oh, that's not what I want. Okay, I think I've messed this up. So we are going to do that. We are going to say, and the other thing that I want to do, might as well just do it now, is I'm going to specify, for me personally, sorry, fingers are a little off. I'm going to specify a local config file for Vim that tells it that I want to open, oh, what is that called? I don't even remember. The current window, I guess. So anyway, I'm going to shut this down. So now if I do that, the window's open. It's that one at the bottom. I have a little macro that I use that moves it to the right side. And so, and then I also have another macro that will execute build.bat. So obviously, I don't know how to type because we have a little problem here. Why is this? Could be this. No file, only buffer one. Okay. My typing is pretty bad today, so let's. All right, so that's what I expect. If I type load up Vim, it does that. If I type I want to load the batch file, the build file, that's what happens. Now, if I type that, that still doesn't work, so it's not that. Just typing furiously there for a little bit, so let's maybe just kind of look over this a little bit. The system cannot find the batch label specified compiler. Oh, yeah, the line that I skipped. There we go. All right, so there we go. So now that build, and we're getting back some errors, and it's probably, oh, yeah, so that's the one thing that I skipped out. So the warnings that I prefer are pretty they're set to treat warnings. This WX it says treat warnings as errors, and then this W4 says that to show all warnings at level 4 and up, I think, or something like that. Anyway, this particular error I don't really care about, so I'm going to go ahead and mark it as to disable it. So now we won't get it. And if we look, we have our little assembler executable and some of the other files that get produced. So if I go ahead and run it, it's not going to do anything. Doesn't crash, doesn't do anything. Let's do something to prove to ourselves that we're working. I will just do printf and hello from the assembler. Right, printf is I believe it's in IO. There it is. And there's the hello. Hello from the assembler. So we have a, look at us. We have a working executable that does nothing, which is pretty cool. I don't want that. Okay, so what I'm going to do is, this is all of our changes, but we need to add some of this to our get ignore. So we're going to wow. There we go. All right, so the first thing is that we're going to ignore the build and the data directory. The build's going to be where we output our files to, and the data is kind of where we have some stuff that we want to have. You know, we're putting it in our C time file. We're going to have some input data that we use pretty regularly as well. We're going to I prefer Vim, at least for right now, for my editor. So I want to ignore swap files, which is what Vim uses as temporary buffers. And the other thing is that the vimrc, which is like kind of your local configuration that you want to do for Vim within this directory, you know, that's kind of a personal thing. That's not something that everybody needs, and some people might want to have things set up differently. So that's going to be something that we ignore, so that, you know, can be different. And then the tags file is also another thing that we use the tags to help navigate within Vim, and I don't necessarily want to check that in because it's not really needed. And if you didn't notice, we I am generating a ctags file every time we do a compile, so that we have the latest symbols. You know, we have access to them to use for navigation purposes. So I think that's pretty good. The one thing that I did forget to do, I don't think I made any commits. I did not. So the one thing I forgot to do was check out to a new branch called assembler, so that we can have this work kind of be coming from that. The build's not really related, but you know what? I'll tell you what. Here's what we'll do. We'll go back. We will remove the assembler piece. So let's double check this. This build file is generic. There's nothing really in here. And so why don't we add So why don't we add that up? My get ignore did not work. Let's fix that. Why did it not take the start swap? That's a good question. What did I have this other one? Let's double check. Yeah, I had that. Let's make sure it's written. Maybe it's not. Ah, it wasn't written. Interesting. Okay. So, sorry, here. So that stuff's fine. That's all from the build file. So why don't we make a commit? I wasn't planning on this, but why don't we make a commit that has us setting up our build file? We will, let's go ahead and add build, and I will also add VS25 shell bat file that lets us set up that environment. So we'll just set up and we'll just do this and we'll say master, right? Set up basic Windows build environment. There we go. All right, now we can check out the assembler. We're going to rebase that on master because I made that branch before the commit, so we should be good now. There we go. And the other thing that I want to do is I'm going to run a little batch file I have that's going to help to keep the commits organized to match up with videos. So the other thing that we need to do is undo the assembler pull-out piece that we did. So now what we have is we have the assembler piece, and let's double check this. The only thing should be main, which it is. So here we're going to say basic assembler command line executable. All right. So that's that. So let's talk about what we want to do next. The assembler is going to need to take in some assembly code, and then it's going to need to parse that file and do all the math and all the other things that need to happen to, and in the end it's going to produce a binary file. That binary file is what we're going to use, excuse me, to pass in and boot up to so that we can boot our operating system. The assembler code's going to be the bootstrap portion of it. Like I said, we had that that binary file that we wrote, and the simplest operating system. So what we should probably do is write the equivalent. Well, I tell you what. We know that we're going to need to read files and write files. So let's go through and start to build out the pieces that are needed to be able to read a file and write a file. So I'm going to go, I think my fingers fell off by a row today or something. So I have an idea here. So I'm gonna just write this right here in main for a little bit while we work, and then when we get to where we like what we have, or we'll think about where we want to put it. So rather than worrying about all that stuff now, let's write some code, get it to do what we want, refine it, and then find a home for it. So how do you read a file? Well, if we come here to MSDN, there's it's kind of odd, but they have an API called create file. Part of the reason why we need a new operating system. Basically has a number of parameters, and based on these parameters, it will do whatever it is that you want, such as read a file or write a file. So we're going to use this to start with, and I think for now, let's move this guy right over here. Yeah, I think for now we'll just kind of write it in here and see where we get, I guess. So the first parameter is going to be the file path. Let's just we'll ignore that for right now. We want to read. We're going to set the flag to file share read. No. Okay, so I like I said, I've kind of worked out a little bit of these details ahead of time. We can see all right. So what we'll do is we'll go through them here and find it out. So the first one's the name of the file. All right, we'll figure that out in a second. Second one's the desired access. Obviously, right now we're trying to read a file, so we want generic read. The next one is the share mode, and it has a table down here of the different macros or predefined names to values, and we want to just do a share read. We're not going to modify the incoming file, so we don't need to do anything in that. We don't have any security attributes, so that's why we pass null. Open existing is the next one for this creation disposition, which basically says that it's only going to open if the file exists. Obviously, your source file has to exist in order for the assembler to read it. So there's no point in creating the file. It has to be there. The file attributes, we're just going to use the normal, which I'm not even sure what it really does, other than just says just whatever. And then the final one, we're going to pass null, which is a template file. Which I don't even really know what it gets used for. We don't need it. Anyway, what we're getting back is a file handle. So there we go. That's what that's going to read the file. The next thing that we need to do is check to see if the file handle, as it says here on MSDN, we'll get back an invalid handle file. So what we want to do is say, hey, if it's an invalid handle value, we want to do something. Otherwise, we want to do something else. So what is it that we want to do? Well, probably should print out like an error message and maybe set the status or the return code to something appropriate. So let's go ahead and do that. So right now the return code's set right here. I'm gonna go ahead and change it so that by default, we have that, and then in here we'll say result equals, let's say -1. We'll go ahead and say, hey, we're going to print failed to acquire yeah, we can do that. Come up here, we'll say so otherwise we'll hey, let's do this. We'll just keep it simple for right now, and we'll build from there. So the one thing I constantly forget is that we have to do new lines in for printf. So we will probably be seeing a lot of forgetting that. The other thing that we need to do is, because we got a handle, we need the close handle. I don't know if it says that in the documentation. Yeah, we have to use a close handle. It's a Windows function to basically release that. Okay, so let's open up the whatever it was that we decided it was called, the current window or whatever. We'll go ahead and build. We get a whole bunch of errors, and the reason why is because, well, it says right there, it doesn't know what handle is, doesn't know what create file A is, doesn't know all these things, all the things. So the reason why is because I forgot to include the Windows header file, which introduces a whole bunch of stuff, but it defines all these things that we need to use Windows. So now you notice that the only errors that I couldn't find that file because I can't, because I forgot the S, and then here I somehow dropped the comma. And of course we have to once again add the stdio standard IO. I always see that and I always think studio for some reason. So if we ran this, it would probably either error out or tell us that it couldn't acquire the file handle, and that's only because we didn't tell it the file that we wanted to load. So I'm going to go ahead and I'm just going to hard code this right now. And so we're going to just call it input asm. So I want the assembler to take assembly files, and I prefer to use ASM in as the file extension and pronounce it as asm. Whatever. So what we need to do is go ahead and create our file here. We'll go ahead and build it. Right. And I also forgot that we gotta do double slashes to escape them. There we go. Okay. So if I run that, hey, look at that. We got the success. We were able to create the file handle. If I tell it something that's not here, like input 2, build it, and run it, there we go. Couldn't acquire file handle to input 2 because it doesn't exist. So look at us, we're reading a file. So we read it, but it's we're not doing anything with it. So what we're going to want to do, I don't think that this is going to I don't think this is necessarily something that's needed. We're going to do it anyways. Is that apparently, and this is all from Handmade Hero, when there's an issue with file sizes and sizes being larger than whatever the 32-bit threshold is, which is probably somewhere around 4 gigs or something. And so if you expect to have files larger than that, you have to do this crazy dance to check to see what the file size is, and you need to know the file size so that you can allocate enough memory to be able to read in the contents of the file. So let's go ahead and go down that path. Not that I really expect people to be writing over 4 gig assembly files, or really any over 4 gig any files in this project. I think it's just more of a good practice to be aware of that little oddity, and to then go ahead and have it so that it will work when you run into that. Reason being is we're going to take this file reading code and we're going to put it in a generic reusable method so that it's not going to be specific to the assembler or any other tool that we have or anything like that. Again, I don't really expect 4 gigs to be a problem for us, but it's like I wouldn't have known about it if Casey didn't talk about it. So we might as well pass along the info that, hey, you should be aware of this. Otherwise, when you get a 4 gig file, your code's not going to work. There we go. So to do this, what we have to do is use this get file size x, and that will populate this file size large integer structure, and we can read out of that the quad part to get the file. So what we'll do, that's the thing that we need to do. What we're going to do is we're going to say, look, you know, that's not really something we totally expect. So we're going to I don't remember what that was. Oh, it would be that. We're going to do that. We're going to say we're we're going to say, hey, this quad part, it's a 64-bit value. We're going to say, you know what, I need it as a uint32, but check to make sure that we're not losing anything if you cast down. Otherwise, in debug builds, it'll alert us that we've lost something, which basically says, hey, we've taken on a file that's 4 gigs. Which again, I really would not want to see what a 4 gig assembly file looks like. From here, what we're going to do is we've done a couple things here that we need to finish out. The other thing that we want to do is, I think it was, we're going to allocate that space by using the virtual alloc call from Windows. Let me look up my little notes about the exact thing for that. Right. So I forget, I should probably be doing this. This is the virtual alloc call. I gotta figure out how I want to, I guess that works. We're going to say oops. So the address is a way to tell Windows where you want the memory to start. At what address do you want the memory to start. Then you can tell it how much you want, and then you give it some allocation flags. We're choosing to use reserve and commit, which have the definition here. And then we're also on the last parameters choosing to say that it's page read write. Which is the protection value of it. Which doesn't even say read write here for some reason, but whatever. Alright, so that's gonna get from Windows some memory that then we can load the contents of the file from the hard disk into memory. There's a lot of work involved in doing all this. Some of it's not pretty. So we're going to, I think this is actually a pointer. Let me get back. So we're going to say, hey, if we get the contents, we want to do something. Otherwise, we'll do something else. So if we get the contents, we're then going to do the actual read of the file. There's a lot here. So, where was I? Yes. So let's look that up real quick. So the read file function takes a file handle, which we happen to have, a buffer to receive the data, which is what we set up with our virtual alloc call, That's going to be our buffer. I've chosen to call it contents. I don't know why I got backwards. The number of bytes to read, the number of bytes that were actually read, and then an overlap structure that we're going to ignore. So first one is our file handle. There it is. Next one is the buffer to read into. The next one is how much to read. The next one is a out value so that we know how much was read. And then that last parameter that we're kind of ignoring. So if that worked, we're going to do something. Otherwise, we're going to do something else. You wouldn't think it would be this hard to read some file, some data, but it is. If this happens, we're going to, you know what, we're going to do this. We're going to say result is 0. Actually, up here, what I'm going to do is I'm going to make this something else. Let's say 1 for now. We're going to we'll work out these return codes in a bit. What would be nice is just being able to read a file and printing out the content, and then we can work on cleaning up the messy code that we're writing. So if that worked, if read file worked, what that will do is this this buffer, the contents, will have the byte values that were in the file. Okay? If for whatever reason the values are different, that means something bad happened. Okay, so we can say here, we expected to read this many byte. I'm going to do a little trick here because I don't like to pluralize things when we're going to do something that's silly just to make it so that the pluralization of bytes doesn't happen when the number is 1, because you don't want to say 1 bytes. You say 1 byte. So we're going to put a little effort in and try to make it, just a little nice. So I keep typing that because, again, we'll see where it goes in the future. So if we have content size equals 1, then that's gonna be an empty string, basically, empty character. And same thing. And I forgot. Oops. I'm gonna go to comma. Come on. Like I said, I forgot the new line. I forget a lot because what I tend to do is I'll write a function or a macro that will automatically add it for me so that I don't have to keep dealing with it and forgetting it. So here we're going to say, we're going to come back to that real quick, and we're going to say that the result is, let's just say -2 for right now. All right, the free memory is So there's a virtual free call, which, as you can see, takes the address and the size and a flag that says what you want to do with it, decommit it or release it. So we are going to say it's the contents, the size is my notes, it says size, if it is released, the parameter must be 0. Okay, so we're releasing all the memory. So the docs here say if you're going to do that, which we are, this must be 0. And so we will honor that request. So there you go, that frees the memory. All right, we're getting close. Hang in there. We can almost read a file. Almost. All right, so in the else condition of the read file, something bad happened, so we should probably do what's normal and just log to the console that we had a problem. Here we want to free the memory as well, because the allocation of the memory took place here before the if condition. I guess we could. Can we free it? We can't free it there because we need to be able to take this contents and do something with it outside of our read file call. Which, like I said, this is going to all be encapsulated in, and it's going to return us. It's going to return to the caller the content. So we do need to do the same thing here. And I guess we'll just, keep going. -3. All right, the last. What's going on here? Oh, okay. Okay, so this else condition is if virtual alloc was not able to return us something, which I don't fully understand when that would happen. So until I do, I'm going to just leave a note that says we should probably do something about this, like log. I really don't expect that to happen, so I'm not going to worry about it now. These other two, the failure cases that we defined here are most likely going to happen in our development, just because of someone having a lock on a file or the file not being there or whatever. They're just more likely to happen where, in our development or in anyone's use or anything like that. These ones I kind of don't ever expect it to happen, so I'm not super worried about it. So we're going to just leave them for now. And so what's going to happen here is I have to be right here. So right here, what I'm going to do is this is where we can use, well, we can do two things. Let's do this. I'm going to I am going to define it up here. If I could type the right key that I want. And right here, we're going to do that. So I'm going to declare it outside, set it inside, close the handle. I'm going to actually, you know what? We could do this. We could say result equals, what did we say? I think 0 was success, which it should be. And you know what we'll do? We'll go ahead and say results -4, results -5. 5. So if results 0, which means it was a success, we're going to, what are we going to do? Let's just print we'll just print the contents. Success, %s, and a new line, and we'll just say contents. The contents are actually U8s. I think that'll work. Let's find out. Oh my, look at all that. Right, okay, I forgot. We didn't define our types or that safe function. Let's go ahead and do that. So I want to say uint8, t is u8. And that should be that. Next we have safe truncation. I think that takes a, I think it's a 64. We'll do, oh, that was bad. Don't do that. Don't do that either. 0. We'll do that. Let me look real quick. Make sure. Not messing stuff up too bad. We want to do this. Values less than or equal to U64. So this asserts what's going to be the thing that halts the program, and it will only happen in debug, so that we know it's okay to do this cast right here. Okay. If did I order that? Yes. Okay. So we need to define what those are. I like this trick. So I'm going to define, rather than write it out, you know, 0x, ffff, you know, whatever, 8 times or whatever it is. We just say, hey, the -1 casted into this. That does it for us. So here's where we're going to use the slow preprocessor directive. Else. Can't decide if I prefer that or prefer that. So what this assert does is it tries to write to a protected value in memory, and Windows will halt on that. So that way we'll get that stop and everything. I feel like I prefer that. Oh my, identifier U8. Right. Type defs are weird. You don't put semicolons, but practically everything else you do. Is that right? No, you do. Oh, right. I forgot to include the file. All right, that cuts down the errors quite a bit. Let me double check that. Yep. Oh no, I did. Okay, getting close here. So byte red's not declared. That's right. Should be bytes red. And no object. Contents is a local variable, potentially initialized. Sure, it won't be, but okay. There we go. All right. That was a lot. Is it going to work? Well, let's do this. We will say hello from input ASM. Look at that. Success. Hello from input ASM. Cool. So there you go. What we've been able to do is be able to read a file. I know it doesn't sound like much, but it's a start. And we have quite a bit of code here. Let's I don't know how I feel about it. Let's clean it up. We shouldn't just leave it in a bad state. So this is all of our good code. Lovely, lovely, delicious code. I'm going to build things out in a way that I prefer to have them. It's probably a little early to do this, but I know that this is where we're going, and so I don't see the point in taking smaller steps. If I know this is how I like it, I'm just going to go ahead and do it. So one of the things I like to do is I'm going to put this type definitions in their own file. So that's going to go oh, I don't know where they're. We're here. I think I'm going to even take it a step further. I'm going to make a common directory in the tool chain so that all the tools can use this. So we're going to say types.c. There we go. There it is. And then in here we say include. We need to go 1, 2, 3. Oh. Couldn't include. Yeah, I'll be honest, that doesn't look right either. Yeah, you don't need double slashes, which is what I thought. Oh yeah, it also helps if you don't say common. You say common. There we go. Can it work with double slashes? It can. I'm wondering if we should leave them just because it's the normal thing to do. I will, even though it looks ugly. I don't like it. So we're going to take these, this stuff, and we're going to do basically the same thing. We're going to call this macros. So it's going to have all of our macro goodness. We still build, okay? We're going to take this function and we're going to put him in a functions C. There we go. All right. And then we're left with, so those things are the thing, those things are pretty basic standard stuff. We're going to want that in a lot of the things that we do. So that's why I pulled it out. What we're left with is the Windows specific code. And like I said, it's over a screen full just to be able to read a file. It's kind of ridiculous. That's the way it is. So let's do something about it. Give me just a sec here. Okay, how do we want to approach this first? Well, reading and writing a file is, oh, you know what? I forgot that we had this guy hard-coded. We should probably fix that. Because it's unlikely that that's going to work for anyone else. And again, not that this really is for anyone else. It's just not a good thing. The way that arguments work in Windows for command line is that the first argument is the name, including the path of the executable. And the second argument is the first argument that the user typed on the executable. So if you say something like notepad foo.text, when notepad runs, its argument list is notepad foo.text. So foo.text is, in argument 1. So where I kind of expect is for people to say the input file as the first thing. Remember, we have to skip over the executable name to get the first thing. Now, if we do this, that's going to be fine. If I run it, it's like, oh, it was null. There's no null file. We have to tell it the file that we want. So now I can tell it the file, and it works fine. Now, the error that we got when we didn't have an argument is not necessarily what I want to say when you pass the wrong number of arguments. What I want to do is do like an argument check or a length check, and then if they don't have the right arguments, then output like a little help message that says, or usage message. that kind of says what you should do. So for right now, what we'll do is we'll go ahead and say if the arg count is less than 2, we want to do something, otherwise we will do this. Okay, and what we'll do here, we'll say results negative. I don't remember where we left off. I think 6 was the next one. We're going to clean up the numbers so that they make sense in a minute. So we're going to say usage is assembler and input file. Okay, so now if we do that, that still works, and if we do that, there we go. Now we have a little bit better message to say what's going on. Okay, let's make it even better. I want to I feel like I want to go ahead and pull this out into its own thing. It's not ready to do that though. Well, maybe it is. So I'm going to we're going to just say Windows API. So I'm gonna prefix all of our Windows specific functions with Windows API, because what I really want to do is call read this function read file, but that's going to conflict with the Windows version of it. So I'm just using that to I'm just doing that to differentiate the two. Okay. Wow, it is not happy about these question marks. So let's just say void. Those are weird. I wouldn't think that it would care. Oh. Sorry. There we go. Okay. Gotta get the indenting right. So what this is going to return is, you notice that there's really two things that this function was supposed to do, or what it needs to do. In reality, it needs to tell us, it needs to give us this back. Oh, let's not do that. It needs to set contents to something. And since it's a pointer, we could pass it in. And then it needs to tell us the result. Ooh, I don't know how I feel about that. Let's give it a shot. Let's see what happens. So I'm going to go ahead and say here the result is, what did we default it to? 1. 1 by default, which just means that's going to end up meaning kind of unknown or undefined, or like we don't really know what it is. So I'm going to do that. We'll go ahead and return that, and this is kind of interesting to me. I hadn't thought about this. We're going to pass in the file path, and we're going to pass in the pointer to really a buffer that we want it to fill. I'm thinking that that's going to work. I hadn't gone this way when I had played around with this before. So we need to set result to whatever this guy says, and then here we need to give it the file path and the contents. And a whole bunch of stuff broke. Oh, right, because the internal is not defined. So, like I said, there's just some basic stuff that, you know, it's nice to have around, and then you don't have to deal with it all the time. But when you're just starting out, you gotta sit here and write it all. And since I know where I want these things to be already, I'm just putting them there rather than having everything sit all together and then deciding at that point to split it out. I think we're going to get to where we'll want it split out. So all this is doing is just, again, this is, like I said, I haven't really learned C before Handmade Hero, and so this is something that Casey does so that he can determine, because static can mean multiple things. He uses this to determine what the actual meaning for static is. In this case, we're using it to say it's a static function. It's an internal function. Okay, so file handle. Oh, I missed. Wow, I missed a bunch. Okay, this is really what we want. What was here before? All that other code. That was really bad. I want all that too. And all this code. Needs to go inside here. Okay. Oh, right, that's an int. Okay, let's just change it to an int for right now. It's a Windows function, so that's fine. Let's double check that we didn't break anything. That works. That's not a thing. Ooh, that didn't work. I wonder why. We said success, but the value, the content that we printed out was null. So that's making me believe that this didn't work. But why wouldn't that have worked? It should have, I believe. Tell you what, let's just take a closer look. And can't make sense of it quickly. We'll go to what I had originally wanted to do. Come on, studio. Right. Wait, what was that? I think it skipped over what I wanted. Oh. Yeah. We're going to have to set the arguments to here. So that, there we go. Okay, so, whoa. Hey, it was so fun, I did it twice. Okay. So that should allocate, and it does. And there's the hello from input asm. Close the handle. And then it comes back. Okay, so again, that's probably just because my not fully understanding certain things. What I really wanted to do, and what we're going to do now, since that didn't work, is define a struct that comes back. So we're going to do status. We'll, I don't know if we're going to need or want the content size, but I figure might as well. You know? And so then this becomes read file result. All right. Yeah. Okay, so what we have to do here is we have to update all of the results to be status. There we go. And we're going to change it so that we don't pass that content in. Instead, we're going to here set that, and then here. Oh, you know what? I wasn't casting the return of virtual alloc. I guess maybe it was doing it automatic. Interesting. We're going to say the results dot content size, and so right here, and right here, and right there, and right here. Okay, so that's that. Oh, we're in main. Duh. All right, so that means that this goes away, that this result is now a read file result. I'm going to go ahead and say read file result. And we'll do that. We'll you know what? I'm gonna do that. and we'll do this this piece inside here. Okay. I guess we might as well pass the content size. Sure. Okay, what did we miss? Oops, if you type the right word. Here we missed one. So that's just result. Same thing here. Whole bunch here. Well, maybe not a whole bunch. Just that one. This is saying what? No, did I do that right? Yep. Oh, because the contents is a void star. Let's go ahead and we'll just cast it for now. There we go. So if we run get the usage, there we go. So we've extracted the reading functionality out into a method. So let's take a look at it now and see if we're happy with it. So there's two things I want to do. One is I don't really want just random numbers as the status. And two is the printfs. I want to do something different with the printfs. I mean, they're okay where they are. I just want to build a little printout functionality. So I'm going to let's tackle the statuses first. So we're going to do an enum for this. And you know, I wonder if we should have been making commits along the way. I don't know if I want to do that at such a fine grain level. Well, at least that's beginning. Okay, so we have success, which is here. We have -1, and that is failed to acquire. So wow, that's not at all. That works. I'm going to change it up. Instead of return negative numbers, I'm going to return positive numbers in particular ranges for things. So this is going to be 11. Because it goes to 11. Actually goes higher than 11. File number unexpected number of bytes read. It's 12, because we know that's 1. Failed to read is 14. We'll get 13 in a second. No, this is going to be for the write. So I'm going to have 13 is unexpected writes, and 15 will be failed to write. Just because I wanted them grouped by status rather than operation, although it is called file operation status, because file status kind of would mean file on disk. All right, well, not a big deal. We can make a change, because there's nobody here to stop me. So in that case, I will go ahead and make that 13, because now I want them organized by operations. Maybe what I'll do is I'll set this to 21, and we'll have like success obviously is its own thing, generic operations, read operations, and then write operations. I like that. Okay. That sounds good. So we got failed to acquire. This one is file operation. This one is bytes read. This one is failed to read, and we have to come back here and fix up our renames. Okay, so that looks a little better. Oh, we got these guys. I have no idea. File operation. Can I spell operation? Status. What one is this? Failed to acquire memory, which should never happen. Oh. File operation status. This one was failed to get size. Failed to get file size information. All right. So those are going to be under the generic ones. So that kind of makes me feel like I made the right choice here. Failed to get information size is technically the next error that could happen in terms of order. Failed to acquire memory happens after. There we go. Okay. Okay, so there's the file op. If you noticed, what I did here was I put the Windows includes not required for either of these structures. So I wanted to put them ahead. You know, I mean, just to try to organize things. So I'm going to go ahead and move these out, and I'm going to put that in a, well, let's switch over here. We have the common directory under the tool chain. Common. So let's go ahead and do the same thing we did before, which is platforms, Windows API. So here we can request a new file buffer, common, platforms, Windows, file, .h. I decided to break it out in this platform Windows things, even though I don't expect to be writing these tools or anything else off of Windows, just as a good practice kind of thing. I didn't see a reason to not go ahead and do that. Okay, so the last thing that I want to do is fix the printfs. Again, there's not necessarily anything wrong with the printfs the way they are. Like I said, I do forget to put the new lines, and there's going to be times when we want to print when we're in debug, and then other times when we want to print all the time. So we might as well split that out. So I'm going to create a little logging. And I'm going to dump this stuff in here. And actually logging should go before the functions in case we want to log within anything in that function. All right, let me pull up my, I guess, cheat sheet. All right, so so we're just going to wrap printf in into a little macro that I'm going to call print. And then I'm going to have my print line, which is what I'm going to generally use most of the time. Those are going to be the two things that if you always want it to print, you're going to use those two. The other thing I want to do is set up some debug prints, because sometimes it's helpful to give yourself a little bit of information. And then these are just going to call the other macros so that everything just kind of falls into place. Looks good. So now that we have that, still building. We're just going to go through and we're going to change these now so that we can just say print line, and we can get rid of that guy. Because we're always going to want to print out the error messages, basically. Here we're not printing. Here we are printing. And here we're printing. I'll take the last one off. There we go. So let's make sure that we got them all. I'm going to take that line out and okay, maybe that wasn't the best way to figure out if we got them all. What we can do is Oh, that was dumb. I don't know why, but if you don't give the right, if you pass fine string with wrong arguments, it like just runs infinitely for some reason, which is really kind of frustrating. Okay, so there it is. It only found the one printf, so we've successfully isolated all the printfs, so now there's just the one. And so we should never use printf in our system. We should use printline, print, debug printline, all that jazz. The other thing I want to do is let's go ahead and move. Ooh, let's not do that. Let's go ahead and move the read function out to its own file. And like I said, we'll go ahead and put it in a common directory for all of our tools. File.c. Come back in here. There we go. All right. So let's double check that we still have a working file reader called assembler. There it is, and there it is. So pretty happy with that for now. I think what I'll do is let me double check what I had going on. Oh, what did I... I had them there. Wow, that was roughly. Okay, let's do one other thing real quick. Because we still have this 6 here, and we still have this 1 here. So let's fix up our return codes. Yeah, I like that. So we know we have an invalid usage, and we're just going to give that a value. Why was that not happy with? Oh, I'm going to try not to sneeze right now. All right, so this guy is going to be used as our initial value, just so that it's like, hey, like, it just never got set. I'd prefer it to be explicitly set to success, rather than just being like, oh, it's always successful. I guess we don't have a use for that right now, so we'll leave it alone. And then here we'll say invalid usage. That fixes that. The other thing that we need to do is I guess this should probably be file operation success. And regardless, this is a little weird, and I don't really know if I'm happy with it, but I'm going to reuse the same, the values from the read file result, or rather the file operation status, and the values within the main. So that's why maybe that's why I put them there. Not super happy with it. I guess we can. If I come here and I put those, oh, because I said struct. Why would I do that? Why would that be a thing? So, so in reality, these two enums, in a way, share the same space, the same number space. So we want to make sure there's not ever any conflict in there, which is why I'm going to put this return codes in file for right now. Normally this should probably be in something else, but just because I don't want to have to deal with having to map a file operation to a return code and then having a return code for every file operation status, I'm just going to kind of cheat, I guess, and do that. Okay, so I think that's pretty good. I think that's what I want. Still works. Still looks good. So we could, in theory, read any file. Doesn't have to necessarily be an ASM file. I think we put the by hand in here. There we go. It stops because it reads a 0 character in the output. The command prompt interprets that as the end of a string and everything. If we had more text in there, it would read more. Okay, so let's take a look at our changes. So what we did was we had a whole bunch of stuff. We have a whole bunch of files that we include. Our main function then returns into, and I like this, it's nice and clean for right now. It's like, hey, did you give me the right arguments? No, here's what you need to do. Otherwise, it's just going to read the file and output the file contents. So that's good. This is our functions file, so it just has the safe truncate. So that's good. Our logging, which we talked about, will enable it so that we have a little bit better control over it, and if we don't have, we're going to want to have a lot of printing to the console, and if we ever wanted to change the way that worked, now there's just one spot because we're always going to use these macros. We don't have to go and find all the printfs and all the code and make massive changes to everything. We can control that here. Here's some of our macros that we defined. So again, we defined like an internal for static so that we can differentiate static to others. We have a definition for U64 max, and then we do have our certs so that we can halt the program, and that will help with debugging and troubleshooting. This one's the big one. This is the file read. As you can see, we have quite a lot's involved in reading a file, apparently, and we built that out so it works pretty good. We have our file header, which could be in file, but it's not Windows specific, so we load that before we load Windows. That could change down the road. It was just trying to be clear about things for right now, until there's a reason where we need to put them together. And finally, we have our types, which we've only defined a handful. The one thing that I did notice when we did these is that we had that static and we had the to-do, and we had to-dos in the file read on the Windows calls that we don't expect to ever fail. We report back a return code, but we're not outputting anything. So what we should probably do is go ahead and do a to-do check and a static check. And again, this is completely from Casey. So what this is going to do is we're just going to have a little local variable, and we're going to, of the file extensions that we care about, and then we're going to call find string, and we're going to pass it a whole bunch of flags, and then we're going to say file extensions, and we're going to do that. All right. And then for our static, we're going to use the same file extensions. We're going to say here, statics found, and that's good. So now we can come over here and we can say miscellaneous to-dos. There they are, miscellaneous static checks, and there's the one that defines internal. We're going to use static for a couple other things, and so we'll fix that up when we get there. But we're going to go ahead and add those two guys. Yep. And we will say implement file reading in assembler. There we go. So that looks good. What did I... Yeah, that's not gonna work. This needs to be %1. There we go. So in theory, if I say okay, there we go. Merge video 1 into December. So there you go. So I hope you enjoyed this. I know maybe it was a little slow or a little weird with me looking things up and everything. You know, I'm doing this more for me, but if you enjoy it, that's great, and I appreciate it. Hope to see you next time. And until then, have a good one.